we're going to look at some special angle and line relationships. So vertical angles are made when two lines intersect, like that. So the vertical angle here are the ones across from each other. So I could call this angle 1 and angle 2, and I would say they are vertical. They're opposite from each other. Or I could look at these two here, angle 3 and angle 4, and they are also vertical. Okay, a little memory device here is kind of neat. When you cross the two lines, it looks like you have a V for vertical and an A for angles. Make sure you complete this on your handout. Next up are adjacent angles. And adjacent angles simply means that they are next to each other. They share a common ray, so 5 and 6 here share this ray in between them. Kind of like adjoining rooms in motels. They share a common wall and they have a door that you can go between the two. Okay, so that's it. As long as they are sharing a common ray, we could say this angle 1 and angle 2 are adjacent. Complete your handout for adjacent angles. Complementary angles are another special type. These are angles that create a right angle together. So here we have angle 7 and angle 8. Together they form a right angle. Or we could say a perfect corner. So a memory device would be to say that it's C for complementary and C for corner. Also, some people say, hey, it's right to give people compliments. A right angle are part of complementary angles. Supplementary angles form a straight line together. So here I'm going to show, here's our straight line. I'm going to have an angle right here for angle A, and then another angle sitting next to it, angle B. Yeah, these two are adjacent because they share a ray, but they also form a straight line together. That makes them supplementary. Where here we have 9 and 10. If we slide them together, you're going to see there's still going to be a straight line, or 180 degrees, and they're going to be supplementary. So a memory device is S for supplementary and S for super straight, because it makes a straight angle. So to classify the relationship between A and B, I can see that they form a perfect corner, and I know it's C for corner and C for complementary, a 90-degree angle. Okay, on your handout, find the relationship between A and B here. Again, they form a perfect right angle. Oops. They form a right angle, which is 90 degrees, so they would be complementary. On your handout, classify this angle relationship. Well, as you can see, they make a straight line together. Here we have angle B and angle C. Yes, they're adjacent, but they are also supplementary. S for super straight, S for supplementary. Also on your handout, classify the relationship between angle C and angle D. Well, they are across from each other, made because two intersecting lines. And they are actually going to be congruent, which means they're of the equal degree. So vertical angles are opposite, and they are congruent. And it's kind of like they make a V and an A. Which gives us 37 degrees for our missing angle of B. Okay, you do this one. So if A is 40 and we don't know B, we're trying to figure out 40 plus what equals a right angle 90 degrees. It would be 50. And we would write this like this. M for measure, the measure of angle B is equal to 50 degrees. Knowing that x plus 115 degree angle makes a super straight line, supplementary, pause the video and find the value of x. Together, the two angles would add up to 180, so subtracting 115, you would get that the measure of angle x is equal to 65 degrees. Again, pause the video and find the value of angle y. So made by two intersecting lines crossing here, we have opposite angles, which are congruent, means that y would have to have the same value, the same degree. So they are vertical angles, which makes them congruent, and the measure of angle y is 80 degrees. Okay, now we're going to look at some special angle relationships that happen when we have two parallel lines being cut by what's called a transversal. So two parallel lines would be like here, and we're going to cut it with the transversal. So here's our two parallel lines, J and K, and cutting across it is our transversal, L. First, let's look at what happens when we're just looking at the inside of the two parallel lines, right inside there. Okay, we're going to have alternate interior angles that we're looking for. They're on opposite sides of the transversal, and of course inside those two parallel lines. So if they're on opposite sides of the transversal, look at 3 and 4. They're on opposite sides of that line cutting across, and they're inside the parallel lines. So they are called alternate interior. Also would be angle 4 and 6. Both are inside the parallel lines, and both are on opposite sides of the transversal. Next, we're going to look at alternate exterior angles. Well, if it's an exterior, kind of like the word exit for an exit sign, they're going to be on the outside of the parallel lines, so somewhere out here. Okay, and again, they're alternate. That means they're going to be on opposite sides of the transversal. So we can see angle 1 is out here. On opposite side of that transversal would be angle 7. And yes, both of them are on the outside or exterior part of the parallel lines. So they are alternate exterior angles. What else are? Well, here's angle 2 and angle 8. Also on the outside and on opposite sides of the transversal. And they are also congruent. Just like alternate interior angles, alternate exterior angles are congruent. Okay, now let's look at corresponding angles. They are also congruent. And what their deal is that they're in the same position on those parallel lines. So let's look at angle 1. It has to be in the same position of that intersection. So here we have a little intersection here. Look at the bottom intersection and find the angle that's in the same position as angle 1. It would be angle 5. Let's try one more. There are 4 sets, 3 more of them. So if we take a look at angle 3, look in the same position of the intersecting lines down below, and we would have angle 7. So angle 3 and angle 7 are corresponding, and that means they're congruent. So other pairs would be 2 and 6, and 4 and 8. So let's find the relationship between angle 9 and angle 13. Well, according to where they're at in the intersections, where the intersecting lines, both of them are in the same position. So that means they corresponding angles. Okay, pause the video and do this one on your handout, looking for angle 1 and angle 5. Well, you see, if you compare the intersections, they are both in the same position of those parallel lines. That makes them corresponding. And since they're corresponding, they are also congruent. Here we have angle 2 and angle 8. Now both of those angles fall on the inside of the parallel line, so I'm thinking they're going to be interior, and they are on alternate sides of that transversal, so they are alternate interior. How about this one? You do this one. For angle 9 and 15, they are both on the outside of the parallel line, so they're going to be exterior, and they are on opposite sides of that transversal, so they are alternate exterior. So if we know that angle 13 is 75 degrees, and we can use that to find out what angle 11 is. Well, they're both on the inside of the parallel lines, and they are on alternate sides of that transversal, so they're alternate interior, and alternate interior angles are equal. So the measure of angle 11 is 75 degrees also. And to find the measure of angle 15, we can see that once we know 11, we know 15 because they are corresponding. Or maybe you wanted to start with angle 13 here and see that it is vertical of 15, and so they are congruent. So all three of those sets are congruent and equal to 75 degrees. Pause the video and find the measure of angle 7. Well, you can see that they are corresponding in the same position. That makes them congruent. So the measure of angle 7 is also 120 degrees. Pause the video and figure out what is the measure of angle 8 here. Well, we can see that angle 6 is here and angle 8 is here. And because they're across from each other, or opposite angles, they're going to be vertical. And vertical angles are congruent. That means they are the same value. So we can say the measure of angle 8 is equal to 78 degrees because of vertical angles.